Great to have you back. In this session, we are going to explore essential database concepts. We are going to start from a fundamental question. Let's take a look at a formal definition of a database. What is a database? A database is an organized collection of data. A database allows users to store, retrieve, and manipulate data. Despite these being the main tasks a database can perform, let me explain more. A database is software that helps us store and manage data. The data can be in the form of numbers, strings, binary data such as videos or images. Databases offer additional features such as backing up data, encrypting data, and keeping it secure. Depending on the database you use, there may be many features you can utilize. It's more than just storing data, right? It does not matter which database you use. These features can easily be found online in the documents of the database. In this section, I just want to highlight that a database is software that can do more than just manage and store data. Now that we are familiar with databases in general, let me explain more about a special type of database that we will work with in this course, what we refer to as an RDBMS. RDBMS stands for Relational Database Management System. Let's review what we have on this slide. A relational database is a type of database that organizes structured data in format of tables with predefined relationship. In this definition, I need to explain what structured data is. Structured data is data that can be stored in the form of a table with columns and rows. Now that we are familiar with a specific type of database, RDBMS, it is time to look over the definition of SQL. SQL, structured query language, used to query, insert, update, and delete data. So SQL is a language that you can use in a relational database to work with data. Let's move on to the next slide. What is a table? A table is a collection of data organized in rows and columns. We usually call the rows of a table records and the columns of a table fields. For example, if your colleague sends you an email and asks you to add a field to a table, they simply mean you need to add a column to the table. If you remember, in the definition of RDBMS, I mentioned that a relational database stores data in the format of tables with predefined relations. Now I'm going to give you more information about relations. First, we need to get familiar with the concepts of primary key and foreign key, PK and FK. PK, primary key, is a column or set of columns that uniquely identifies a row in the table. FK, foreign key, is a column that establishes a link between two tables by referencing the primary key of another table. But how can we create a relation between two tables using two columns? To have a more visual view, let's move on to the next slide. Just suppose we have a big table like this with multiple columns to keep track of the results of runners' races. Each record or row refers to the result of one athlete in a race. Clearly, you can see that we have to repeat the first name, last name, and gender of each athlete in the table. This is what we call redundancy. Instead of repeating values in multiple rows, we can store this information in another table once. We have done this. If you look at the tables, we can refer to each runner by the value of runner ID column in the races table. In this scenario, we call the runner ID column in the races table a foreign key. which refers to the primary key of the runner table, a unique column in the runners table. These two columns, one in the races table and one in the runners table, could create a form of relation between these two tables. Just as an example, you can see in this table that we have runner ID 201. We can find this runner in the other table if we need more details about him. This will help us save space and establish a clear relationship between these two tables. In short, we will store only the runner ID instead of repeating the first name, last name, and gender each time. The details for each runner ID will be stored in another table once. Finally, the scenario that will be followed in this course. Our dataset consists of 3 tables which shape runner's record tracking system. Almost all of these examples will be implemented on these tables. You may be surprised how many questions can be asked or answered by even a small dataset. These are the tables: runners, race results, races. In the next session, I'm going to guide you through the installation of PostgreSQL. If you already have a test environment which is safe to execute the queries, you can skip the next session. Also, you can use many online tools to run SQL statements. Even if you don't have the possibility to install a database, simply put a piece of paper on your table and write the examples on it, since the commands are not too long and you need to learn the concept. The concept is more important. Thank you for watching and see you soon in the next session.